All right, welcome back. We are GAME 2014 in the fall 2020 semester at George Brown, and it's week 6, part 1 of our broadcast. We're talking about the factory method pattern today and a bunch of other things. Let's start off with where we are today. Right now we're sitting at week 6. Again, it says assignment 1 part 2 due in the outline, but actually, like I mentioned last time, assignment 1 part 2 has been moved to the Sunday of week 7. Okay, the Sunday of week 7. So no, it's not due this week, it's due next week. Okay, just like we talked about. Today we're going to be talking about the lab, our factory pattern. We're going to talk about what that is. And next week, you're going to get a practical test starting in the beginning of the week. You'll have the entire week to get it done. It's going to be an in-week assignment. I'll probably give you a template to start with, so you don't have to start from scratch, to save you some time. There'll be some requirements for you for your in-week assignment that you'll have to put together, and it'll be worth 15% or so of your grade. So it's going to be worth more than the midterm test that you had, or the first test, the theory test that you had on mobile basics, okay, which most of you did very well on. So that's coming up next week. So this week, you've got a lab that I put together, and next week you've got 2 things. One is the assignment 1 part 2 on Sunday, and the other one is your midterm test, if you will, a practical test that's going to be due on Friday, right? You can do it anytime. You can submit it anytime before Friday if you want to. And again, I'll try and make it so that it is timed for a 2-hour period. So it's not something that's going to make it work. I'm not going to make it last for the entire week for you. And if you make it last for the entire week, that's a different thing. But I'm going to make it last, I'm going to time it for 2 hours. Okay. So again, assignment 1 part 2 is due next week. Our lab 4 is due at the end of this week, right? Josh said his would take 4 to 8 hours. Yeah, I know. But his is more involved than mine, and I'm not going to do it that way. I'm going to try and make it so that mine is a little bit less crazy than his. But yeah, I know you're going to have a lot going on. That's why I'm making mine a little lighter. So we're going to be talking about something called the dependency inversion principle, the factory design pattern, which is also called the factory design method. 25th. It should be due, if I'm not wrong, it's due next week. It should be due next week on the Sunday. But if it's due the following week on the Sunday, maybe we'll do that, Kevin. Maybe because but then it'll kill your mid-semester break. Because you get a mid-semester break, yeah? It's 25th. Okay, well, we'll leave it there. If it's the 25th, it's the 25th, right? But let's go up on Blackboard and check that out for a second, just to make sure when the assignment is due. Because that should say, it shouldn't say week 7 anymore, right? So, yeah, it says week 7, October 25th. That's my bad, but that's okay. We'll leave it there. I don't mind. We'll say that's really week, mid-semester. That's like mid-semester break. All right, so that's okay. I'm fine with that. If you guys are good with that, I'm good with that, right? Okay, I'm good. I'll leave it. Let's leave it then at that. Then let's leave it at Sunday, October 25th. That'll be so that's not really week 7. It's like week 8, right? That's all. Okay, someone's going to ask me about that for sure. Let's get back to this. All right, and we're going to talk about simple animation. We'll try and make a factory design pattern work in our code, very simple version, and we'll go from there. All right, so we've talked last week about design patterns, and with design patterns, we talked about an optimization pattern last week called the object pool. Hopefully you guys enjoyed that one. This week we're going to be talking about the factory method pattern and the abstract factory, and they're related. Okay, that's why I'm kind of putting them together. There's other creational patterns like the builder pattern and the prototype pattern, but I'm not going to talk about those today. Okay. So really, one thing we want to talk about before we want to talk about the factory pattern is this idea of dependency inversion principle. The dependency inversion principle is part of something called the solid design principles. Solid design principles are single responsibility principle, the open-close principle, Liskov principle, and so on. There's one that we care about is the dependency inversion principle, the D in the dependency inversion principle, the solid. And what it talks about is high-level modules should not depend on low-level modules, and both should depend on abstractions. So when we think about abstractions, in my mind, I'm thinking abstract classes or interfaces. Remember that what I'm thinking about is C# right now, not C++. And when I say interface for you as C++ developers, native, you'll be thinking about the .h file, right? Because that's the interface for the CPP file. In many ways, that's what we do when we create an interface in C++. We have a .h with no CPP, and the .h doesn't have any implementation details, just the declaration. So we declare methods in the .h, and we implement them or define them in the .cpp. But we don't have a .cpp, so all we do is create virtual methods, pure virtual methods, that allow us to, when we inherit or implement these methods, then we must override the method that is part of the interface. Okay, and we'll talk about that in a bit. So similarly here in C#, we do the same thing. We have an interface type. It's not a class, it's something called an interface. And the interface is how we're going to identify different objects of type. Because there's two ways we can identify objects. One is through the class, and the other one is through the interface. So the factory method is really also known as the virtual constructor, is a creational design pattern that provides an interface for creating objects in a superclass, but allows the subclasses to alter the type. So it allows us to have this the polymorphism still to work, basically, is what we're doing. So here's the problem. Imagine that you're creating a transportation simulation, and the first version of your app can only simulate transportation by trucks, so that the bulk of your code lives inside the truck class. And after a while, it becomes really popular, and you know what? Someone's asking for a sea-based transportation thing. But you know what? Because most of your code is in the truck class, the movement and all the methods to transport, goods, let's say, from one part of your simulation to the other, you need to do a rewrite. And so what do? Right? Well, I mean, sure, you can add ships into the app, but what about if you want to have something like planes or spaceships or TARDISes or whatever in the future, right? You don't know what you're going to need. So if there's going to be transportation across different modes, right, different methods of transportation, then now there's a reason for us starting to, kind of use another pattern. All right, which is the factory pattern. So we'll talk about this. So the factory method pattern suggests that you replace direct object construction calls using the new keyword. Again, in C++, you don't use the new keyword unless you want to allocate dynamic memory, right, on the heap. In C#, we always, for the most part, use the new keyword in order for us to instantiate objects. That's what we do. Now in Unity, there's a slight difference. Because in Unity we don't need to use the new keyword. We use instantiate. Okay, instantiate actually is in many ways a factory of its own. It creates an object, and it depends on the type of object we pass in. In some ways, the factory pattern is being used all the time in Unity, right? Because depending on the type of prefab that we pass into the factory pattern, let's say for example our bullet manager. Right, it's going to create the bullet that we want based on the prefab that we select. That is in effect the factory method. All right. However, we can also have our own, and we're going to talk about that today. All right. So the factory method again, we replace the new call here when we replace the new call inside the factory. So the factory itself does all the instantiation. Okay, it doesn't happen by the client anymore. The client program. It happens inside the factory. And what we want to do is when we create objects in the factory, those objects are called products. This is just naming convention. Okay. So it kind of looks like this. Now, if you're not used to UML, that's what this is, a little UML diagram, right? There's a couple things to note here. All right. One is in a UML diagram, and again, I'm assuming, guys, that you don't know UML. okay, that you've never been shown it. And if you have, by me or by somebody else, bear with me as I go through this one more time. Okay? So UML diagrams for classes look like this. They're square or rectangular. The top part, this area here, is the name of the class, right? That's where we put that, all right? And then in the middle area or middle section, that is where all the attributes go, or fields, member variables, call them what you like, right? That go here. And down in here are all the methods and functions, also called operations. So these ones usually are called attributes from UML, on UML perspective. And these ones down here are called operations. Okay, so that's the class. This defines a class. If a class name up here is italicized, like this one is, logistics, it means that it's an abstract class a lot of times. Okay, an abstract class or an interface. Plus means public, and minus, if you see a negative sign, it means private, right? If a method is in what it shows here, if a method is italicized, it means it is abstract and must be overwritten by the classes that inherit from it. The arrow that goes from this class to this class, as it points up with this open arrow like this is a generalization, which indicates that this class is inheriting from this class. So road logistics inherits from logistics. Because logistics has defined a abstract member function called create transport, road logistics must override the create transport method. And notice that this is not italicized. So italicized, abstract, not italicized, not abstract. I mean, it's a concrete object, right? So there's two classes here, road logistics and C logistics. One thing to note is that our delivery plan, or our plan delivery, returns a type of transport object, a transport object. And a transport object could be either a truck or a ship. We don't know which one. We're just going to return one of those, a truck or a ship. Okay? So at first glance, it looks like this change is pointless, right? It's like we're taking the new keyword or the instantiation and we're putting it inside the factory instead of the class, the concrete class. But actually what it allows us to do is gives us flexibility. It allows us to decouple our instantiation from our client. The client is only going to request an object or a product from the factory. And the factory is going to take care of all the configuration as well as instantiating the object properly. That's what it's going to do. Okay? So here's the interface as an example that each of the objects have. Because maybe when I deliver something, when I deliver it by land, I deliver it in a box. When I deliver it by sea, I deliver it in a container. Either way, I have a deliver method. The deliver method comes from the interface, transport. We say when we have a class, when I inherit from a class, I use the colon, right? Whether it's in C++ or in C#, I use colon to indicate that I'm inheriting. Most of the time we inherit with Unity, we inherit from mono behavior. Okay, mono behavior. Okay, here we're not inheriting from mono behavior. We are implementing, we say we are implementing a interface. We use the implement keyword to indicate that we're going to use or attach the interface in the same line where we inherit. So we have inheritance and implementation. And the way we do that, it looks like multiple inheritance, right? But actually what it is we're inheriting from the class and then comma, we use a comma for the syntax, implementing the interface. So why do we bother? Because now we can say that the whether it's a truck or a ship, the truck has a deliver method. It has a transport interface. That's what it has, right? But it is a vehicle, right? Let's say vehicle was the superclass. So has a and is a. Those are two different ways of thinking. So then both the truck and the ship has a deliver method. But the truck and the ship, right? This truck and ship, right, as an example, maybe is a vehicle. Okay. So why is this good? Because when we create transport, this little hole, this little like dot and then dash 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 means that the create transport method actually returns, right, a transport type, which means it returns a type of either a chip in this case, or ship, or a truck, or it could be something else. We don't know which one. It really depends on the configuration details that the factory is asked for. So if I pass in some parameters, like let's say for example, I pass in an enumeration that says I want a ship or I want a truck, right? Then the create method will configure and instantiate the right object and return that type of object back as the object that we need. We're not going to be able to do everything exactly the same as this because of Unity. If I was just working within C#, it would be no problem, right? But Unity uses game objects, and it's going to be difficult for us to cast it as a type of game object at the end. We'll see how it goes. All right. So again, for the solution for both truck and ship classes should implement the transport interface, which declares a method called deliver, right? And this deliver method, we should probably make it so that you can see it better, right? The deliver method, each class implements this method differently. Trucks deliver cargo by land, ships deliver cargo by sea, like we said. And the factory method in the road logistics class returns truck objects, whereas the factory method in the sea logistics class returns ship objects, right? But it calls the factory, the transport or logistics factory, to try and get whatever object it needs. The road logistics and the sea logistics classes, they are the concrete classes that are the clients of the factory. Okay, the factory is an object that stands alone. All the implementation details are there, right? The instantiation details. Road logistics and sea logistics, they just ask for the object that makes sense for them. And the factory will take care of the rest. So now imagine if I have all these transport objects. These are all transport objects in my logistics application. I have the deliver method, and I can add more of them, and it doesn't matter. The client doesn't care. Here's what it looks like from a structural perspective, right? I have my creator, which is my factory, right? I have the product, which is the interface, right? The product does stuff, whatever that is. And I have two types of objects that are linked to the product. Think about these as the game object prefabs, right? I have product A and product B, right? Depending on the type of product that is called for by a concrete creator A or concrete creator B, the factory is going to instantiate the type that is asked for and return them back to those creators. That's how it works. So I can have a number of creators and a number of prefabs, and by the way, they don't have to match. I can have a ton of prefabs but only 3 creators, and really depend on what I'm looking for. 3 concrete creators is what I'm saying, and they can ask for whatever object they want from the factory. Clear? So check mark for clear, X for I don't understand why this structure, Tom. I have no idea. Yay, I'm actually getting some check marks. This is good. This is kind of a difficult concept only because for some people, the idea of an abstract... Sorry, someone had their hand up. I just canceled that. Does someone still have their hand up? Is there a question, or is it Patrick? Patrick, give me 1 second. When we talk abstraction like this, the biggest challenge from an understanding perspective is like, wait, how does this fit in our game development process? Like, where does this fit? And we'll talk about that in a second. Patrick, go ahead. You're live on YouTube, though, just letting you know. If you want to ask a question, you can do it through typing, and there you are. So there's one deliver method which looks for which transport is and goes from there. Yeah, let's go back up to that. So just an understanding perspective. So I make an interface. The interface itself is it has no definition of deliver. Deliver is defined in truck and in ship. Trucks deliver differently than ships do, and so the deliver method is something that's being defined in here. Okay? Truck and ship, think of these as prefabs. These are the prefabs, right? And all I'm doing is I'm saying that both truck and ship implement the transport interface. The transport interface has a pure virtual function called deliver that must be overwritten and deployed inside of truck and ship. This is the relationship, okay? And it's decoupled from the implementation details. The implementation details is when my logistics factory, right? My logistics factory, it uses create transport and create, or it has create transport, and create transport is being called by road logistics or sea logistics. Depending on which of these classes call the create transport, the logistics factory is going to detect which type of transport type to return, whether it's a truck or a ship. Okay, it's going to be based on the type. Okay, let's get moving to this one. So I've got this creator stuff here. And so really what it says, the product declares the interface, which is common to all objects that can be produced by the creator and its subclasses. Concrete products are different implementations of the product interface. So that means these are the prefabs. That's what those are. The creator class declares the factory method, right? So the factory method itself, the factory. And the concrete creators override the base factory method, so it returns a different type of product. So it returns either a ship or a truck. Okay? Again, this is one way, the classic way of doing a factory design pattern. When does this apply? It applies when we don't know beforehand the exact types of dependencies the objects my code should work with, and the factory method separates my product construction code from the code that actually uses the product. And that way it's easier to extend the product construction, and it's more, because it's decoupled, it makes it a little bit more easier to test, if you will. Okay? The other reason why we want to use it is if you want to save system resources. So it combines really well with object pools, as an example, right? I have a large pool of objects and I want to save system resources, so I'm going to instantiate a bunch of objects in a pool, or reuse some objects in the pool, because I don't have to just create them. That's not the only way I can use a factory. It doesn't have to use the new keyword. It can also return references to objects that already exist. Okay, which is another way we can use it. Okay. Advantages: we avoid tight coupling. We use the single responsibility principle, which means that your product creation code is in one place and it does one thing. And the open close principle means that we can introduce new types of products into the program without breaking existing client code, which is what what's the open close principle is known about. Disadvantages: code becomes more complicated because we have more abstractions. As soon as we have more abstraction, it's more difficult to visualize how things are pieced together. And if you're someone new to the code base, you might be confused as to how things are what things point to what things. Best case scenario is when you're introducing the pattern into an existing hierarchy of creator classes and you want to make use of the factory pattern to simplify. And that would be the best case scenario. So if we understand what factory is, then what the heck is abstract factory? So abstract factory is a factory. But imagine if I have a whole family of objects. For example, I have a spheric factory or a pyramidal factory where I can create different types of furniture. Spherical furniture and pyramidal type furniture, right? Here's the problem. Imagine that you're creating a furniture shop simulator. Your code consists of classes that represent a family of related products. For example, chair, sofa, and coffee table, right? Furniture. Several variants of that for this family. For example, products, chair, sofa, and coffee table are available in these variants: modern, Victorian, and Art Deco. So now I have a whole variation of the same products. Where I think about this is, when I first saw this, is different kinds of swords. Long sword, short sword, as an example, two-handed sword, right? Great sword. They're all swords, they all cut the same way, but they're different shapes, right? Or you could look at them as different kinds of swords of the same type. They're all long swords, but one long sword is more fancy, or it's a ceremonial sword, as opposed to a a regular longsword, right? It's the same idea, but more or less you have variations of the same product, okay? So how do I deliver the right product variation when I'm asked to by the client? So let's suppose I have a sim, and the sim says, listen, I ordered some chairs last week, but I guess I need a sofa too. And they order it, but they get the wrong one, right? How do I know which one to deliver? If they delivered, you know, kind of these classic Victorian chairs, how do I know what chairs they have? I don't know the chairs they have because by the factory pattern, I got chairs. Chair, right? Because they all inherit from the chair interface, right? But what I'm looking for is a chair that also is of type Victorian, right? So, I mean, again, a couple ways to solve this problem, but let's see how we can solve it. So I don't want to change my existing code base. I have a bunch of different product lines. So what I want to do instead is I want to use a different method. So solution, we use the abstract factory pattern, which basically we declare interfaces for each distinct product of the product family. Example, chair, sofa, or coffee table. And then you make all the variants of products follow those interfaces. For example, all the chair variants can implement the chair interface. All coffee table variants can implement the coffee table interface, and so on. But what you do instead is create two different factories, right? We're going to talk about this later on. So here's the interface for chair. So all chairs have legs and you can sit on them, right? That is the methods that the chair interface has. And the same thing goes with the coffee table interface or the sofa interface, as an example. They have other methods that each of the variants are all aligned with. The difference between a Victorian chair and a modern chair is the shape, right? Let's say. But the methods, the way they're used, is the same. Okay. So we just declare this abstract factory, the next step, and an interface with a list of creation methods for all the products that are part of the product family. For example, create chair, create sofa, and create coffee table. Those three things, right? And then these methods must return abstract product types, right, represented by the interfaces we extracted previously. For example, chair, sofa, and coffee table. So they have to return those things. In other words, when we look at the diagram, here's your furniture, your abstract furniture factory. And this is great because furniture factory doesn't mean as much as Victorian furniture factory or modern furniture factory. The words mean they have a better context than just plain furniture factory. Furniture factory can return everything. What this abstract class has, also called an interface, but really what it is an abstract superclass, right? You can see these, there's two ways of doing this. Make an interface called furniture factory, and Victorian furniture factory and modern furniture factory implement that interface. So it must have create chair, create coffee table, and create sofa that are overridden. You override those inside of the concrete factory. So that's what these are, right? This is the abstract factory. These are the concrete factories. Each of the concrete factories still are able to create chairs, coffee tables, and sofas as products, but their style is going to be different depending on which of the, because we're going to override each of these, the implementation of each of these methods inside the factory class itself. Right? I know it's kind of sometimes hard to wrap your mind around, but the idea is that you define these methods, or sorry, you declare the methods here, and they're overridden and defined in detail here. Okay? So again, it's like, give me a chair. Well, I have a name, you know, but I don't care. You factories all look the same to me, which is true, because they don't care. The client only cares about the chair. They don't care of the type of chair. All right? They're all abstract interfaces, and they're returning a type of chair. We don't know which type. And that's good. The more abstraction means the more types of chairs or product lines I can add, and at the end, it's not going to break my code further down. So here is the diagram for the abstract factory. The abstract factory interface or abstract class. In C# we have the abstract keyword and the interface keyword that we can use. Not so in C++. In C++ we flag a class as abstract if we have one pure virtual method, right? Or if we make the destructor pure virtual. Okay, that's the two ways we can do it, right? abstract class. But here we can make it either an interface or an abstract class. Either way, Concrete Factory 1 and Concrete Factory 2 have to inherit from or implement, depending on which one it is, if it's an abstract class or interface, from the abstract factory itself. This thing, they're not defined. They're just, like we said, they're very high level. But notice it returns product A or product B. We don't know which variant of product A or product B. That's going to be defined here in the concrete factories. They are going to tell you which variant is the one that they want in their interfaces. Okay. So it's very similar to the factory, but think about this as a prototype for other factories, especially when they're related like this. All right, so I'm not going to go through this because this is basically what we talked about before. One thing is applicability. When do I use abstract factory? When my code needs to work with various families of related products. I have different kinds of weapons, and each of these weapons also have variants. Like, for example, battle axe, hand axe, great axe, right? Maybe it's a size variant that we're talking about. Or it could be a style variant, right? Great axe of the plains, great axe of the barbarians, great axe of the, the wilds, turkeys, I don't know, making it up. But different kinds of great axes that are very similar. They might do similar damage. They might have similar properties, but they look different. Maybe they have a different texture, as an example. But they're all considered great axes. Okay. Abstract Factory provides you with an interface for creating objects from each class of the product family. As long as your code creates objects via this interface, you don't have to worry about creating the wrong variant because it doesn't matter. All you care about is that it's going to return the type of axe you want, as an example, in the concrete factory. But the abstract factory just cares about creating that type of product. So advantages, again, you can be sure that the products you're getting from a factory are compatible with each other. So they're all, again, going back to that axe example, they're all great axes. Every one of these ones is a great axe, or every one is an axe type, which makes more sense actually for us because there's not like in different games, there's not like so many different types of great axes. But let's just suppose they're axe types, right? Or maybe there's sword types, different swords, different axes. I'm saying from some kind of battle game or role-playing game. You avoid tight coupling again between concrete products and client code. All right. They're all doing great. They're all trying their best. Thanks, Kat. Single responsibility principle again. We extract the product creation code. And again, it's happening inside of the factories. Open close principle. That's in there again. You can introduce new variants of products without breaking existing client code, which is a really good thing, right? Disadvantages. Again, the code becomes even more complicated. Why? Because now we're adding different interfaces, not just for the products, but also for different factories. Okay. Here's some examples. So for games, how does this work for games? An enemy spawner. Create an enemy interface, step 1, that has an attack action method. Create a concrete classes that implement the attack action method. Each attack method will enable different types of attacks, melee, ranged, what have you, right? Use the create method of the factory to instantiate the required enemy object. So do I want the enemy that has a melee attack or the enemy that has a ranged attack? It really depends on what I've asked the factory to create for me. All right? Bullet creator. I have a bullet interface that has a payload method. Each payload method can do different types of effects. Explosions, area of effect, different types of damage, the amount of damage, whatever. Right? Use the create method of the factory to instantiate the required bullet type, right? And that's how the factories would work. A lot of times when we do this kind of thing, the structure that we use a lot here is switches. We use a switch type structure. So we pass in the requirements into the factory. The factory uses a switch case or if-else kind of conditional statements to say, okay, the user is looking for this type of product. Let's instantiate that and return it. But the type they return is not the specific type. It is the generic interface. The type that's returning is of type of that interface type. Okay, that's the key, right? So that way it becomes more generic. All right, questions around the factory or abstract factory. Again, this is going to be used in a future test where we do a quiz type theoretical test. The next theoretical test coming up will include anything we haven't covered in the last theoretical test. So it'll be slightly bigger than what we had last time. Okay. All right, let's move on to the second part. What I'm going to do, because I know people like to take short breaks, is I'm going to stop recording at this point because the next part is going to be the Unity demo. I'm going to stop recording this at this point, and then we're going to get back together. Right now it's 12:40. Let's take 10 minutes, right? And when we come back, we're going to start Unity. To prepare for this, because it's going to take some time for you guys to do this, what I'd ask is that you go up on our content for today, right? So if you look at content, if you go into week 6, there are 2 things to download if you haven't done it already. Download the starter code from GitHub and download LD Player. So LD Player is what we're going to be talking about very shortly. LD Player is, in my mind, an easier virtual machine to use than Genymotion. I like Genymotion a lot. I've been using it for years, but I found that when I was setting up LD Player, it took me way less time and was way less complicated than what we did before, and it worked. Some people have trouble with Genymotion or getting Genymotion to work with Unity. I'm going to help you set up LD Player after this short break, and we'll get it going, and you'll see it doesn't take long at all. All right, so let's take 10. So we're looking at 12:41. We'll come back at around 12:51 or thereabouts, and we'll start recording again after that. So I'm going to stop recording now, and I'll take a few questions before we take a break.